Hi, I'm Mrs. Burns and welcome to Lesson 6 of our chemistry unit. Today we will be looking at naming compounds that include polyatomic ions. But before we get into what this new word means, let's review a couple of things. First of all, ionic compounds are between a metal and a non-metal, and in this case the electrons are actually transferred. Now we keep reviewing this because it's very important. Covalent compounds, however, the electrons are shared. So, a metal is multivalent if it forms ions in more than one way. We learned this last day. And today we are talking about polyatomic ions. So polyatomic ions are made up of more than one type of atom that are joined by covalent bonds. So we're getting into covalent now. And the whole group, not the individual atom, carries a positive or negative charge. The whole group. So for example, nitrate, which is NO3 minus, that whole group, the nitrogen and the 3 oxygens, all carry that -1 charge. There is a really great table in your textbook on page 192, table 4.11, and also in your data booklet, and it lists all of the polyatomic ions, their symbol, and their name. You need to get very familiar with this so that you can recognize them quickly and easily. So what do you do with these guys? How do you put them into a naming category? So first of all, you need to identify the ions that you're working with and what their charges are. Is it a metal? Is it a non-metal? Is it a multivalent metal? Is it a polyatomic ion? Then you need to determine the ratio, how many of one versus how many of another. Cross over for your subscripts. Remember our classic example, Mg2 plus, P3 minus. We cross over to the bottom, so we have magnesium 3, phosphide 2. Don't reduce these for covalent compounds. And then we want to use brackets around. So if we have NO3, we want to use brackets around that to show that we are keeping them all together if the subscript applies. So let's practice some of these. First one, iron is our symbol here, Fe. And then here we've got this weird OH is together with the brackets. So if we look in our data booklet or on table 411, we see that this is hydroxide, OH, and it has 1 negative. And so that works because O negative, and this has a 3 subscript, so this is 3 plus, iron 3 plus, and this 3 plus crossed over to the bottom of the hydroxide. So Fe3 plus would be iron 3 hydroxide. Okay, let's try another one. Here we have Mg, so this is magnesium. We know that magnesium carries a charge of 2 plus. And here we have this PO4. And that's in brackets so it sticks together. And we know that if we reverse that crossover, that this should be a 3, and we know it's going to be a minus because one will be positive, one will be negative. So here, PO4, 3 minus, we can look it up in our data booklet and see that this is phosphate. So this is magnesium phosphate. Now notice, phosphate, that we have phosphate here. In our last example up here, this was magnesium phosphide. So it's very important to make sure that you write the names correctly because it's a very different compound. Okay, let's try the opposite way. Tin 2. Well, tin, the symbol for that is Sn, and if it's 2, then it's 2 plus because it can be, it's a multivalent metal. And cyanide, now that at first looks like it probably could be in the periodic table, but it's not. It's a polyatomic ion, and we can find that in our data booklet. The easiest way to know, oh man, should I look through that whole periodic table or not, is to really get familiar with your data booklet. So cyanide is Cn minus. So if we do that crossover method, Sn, we don't have to write that secret 1, and then CN2. Now we do need to use brackets here, because if we don't have brackets, this 2 is only referring to the N, and that's wrong. So we have to say SN tin, and then CN with brackets. The 2 then applies to both the N and the C if it's in the brackets. Last example, ammonium nitrate. So ammonium, that's also not in your periodic table. That is one of these polyatomic ions, and it is NH4+. And nitrate, be careful, there's nitrate and nitrite. Nitrate is NO3-. So when these come together, we see we have a 1 plus up here. Going down, we'll make a 1. 1 up here, we'll go down, make a 1. So we don't actually need to write any subscripts. NH4, NO3. There you go. So that's how you name compounds that include polyatomic ions. We will practice this all day next class.